Okay, so it says answer the following questions. Classify as always, sometimes, or never. A natural number is a whole number. What do you think? Is it always true or sometimes true? Always true. Let's talk about why. So what is a natural number? Do you remember? Yeah, exactly. 1, 2, 3, 4, etc. It's your counting numbers. What's a whole number? It's your counting numbers, your natural numbers, and 0. So every natural number can be found in your whole number set. So if 3 is a natural number, it's also a whole number. Does that make sense? A natural number is negative. Never. Why is this never true? Because it's your counting numbers, right? Somebody said it earlier, 1, 2, 3, 4. We don't include our negatives. We don't include 0. A rational number is a real number. Always. So there was no sometimes on this. What's a rational number? It can be written as a fraction. What else? A terminating decimal, right. So if it's a decimal that comes to an end, it's a rational number. What's an example of an irrational number? Pi. Pi, square root of 2. Those are irrational numbers because, it's a comma, they go on forever. So pi is approximately 3.14159, etc. Questions on the bell work? Okay, like I said on these notes, if you understand a concept and you don't feel the need to write it down, you don't have to. That date is for last year. It is actually the 31st today. So I'm going to go ahead and write that in, 8/31. So we're looking at section 1.1, which is just solving single-step linear equations, linear meaning line. It says an equation that can be written in the form ax plus b equals 0. A and b are constants, and a cannot equal 0. So that's the definition of a linear equation in one variable. Basically, just the equations that we're used to. So, for example, 4x plus 1 equals 5. Now note that in the equations that we're solving for with that single variable, it doesn't have to have a 0 in the end. It says that a and b are constants. What's a constant? Do you know? Yes. So that's a great guess. It doesn't change, and it has a similar meaning in mathematics. It's just a number in your equation. So it's not something, in one sense, when we plug in an x, we're plugging in a specific value. That constant is just going to stay that number, right? So it is related to that word. So your constants here are 1 and 5. They're just numbers. Unchangeable values in your equation. Now, we talked about, or you've talked about before, solutions to equations. And just know that solutions are what make your equation true. Sometimes we'll run into situations where you have infinitely many solutions, meaning every real number is a solution. You'll have no solution, and you'll have one solution, sometimes more. So in order to check to see if something is a solution, all we have to do is plug our value back in. So if we solve for x in the first problem, and we subtract 1 on both sides, subtract 1, and notice that I'm doing this one line at a time, and that's what I expect you to do. When I was first teaching, I didn't teach Algebra 1, I taught Algebra 2 and Geometry, and this wasn't really a problem then, but it was a problem the first time I taught Algebra 1. Some of you are accustomed to doing everything in one line. I do not want you to do that. So you're going to subtract 1, and of course you get 4x equals 4. Also note that my equal signs are lined up. I expect the same thing from you. And then I'll divide by 4 and divide by 4, and I'll get x equals 1. If I want to see if this is true, I just plug it back in, of course, and see if I get 5. If I get the true statement 5 equals 5, then I know I did it correctly. Do you have any questions for me? All right, I'm going to go ahead and move on to the next slide. Inverse operations. Yesterday when we played our little activity game thing, we talked about the inverse property of addition and the inverse property of multiplication. So when we were matching those properties like associative, commutative, and inverse, for example, we said that we have an inverse property that says that for addition, let's say I have the number 4, its additive inverse is negative 4, meaning that if I add a negative 4, I get 0. With the inverse property of multiplication, I'm not trying to get 0. What am I trying to get? Do you remember? Yes. 1. Right. So 4's multiplicative inverse is 1/4, and that equals 1. And all those two inverse properties are going to be applied to our equations in order to solve them. So you just want to think opposites. Opposite of addition, opposite of addition is subtraction, opposite of multiplication is division, etc. Now this part that says they produce equivalent equations, inverse operations, what does that mean? Well, that means that, let's go back to that first problem that I looked at. 2x plus 1 equals 5. The first step to solving this is, of course, subtracting 1. When I do that, what I've produced is an equivalent equation. All that means is that this and this are the same thing, they're just in different forms. Does that make sense? And then I'm going to keep going to solve. So how do I solve for x? Yes?
So today's one, I think it was for x, not 2x.
Oh, that's okay. This one will work. So how do I solve for x in this step? Divide by what? Divide by 2. And then I get x equals 4. This is also an equivalent equation. And then this allows me to determine what the value of my variable is. Yes? Oh yeah, sorry. X equals 2. Thank you. Long day. Questions? And then, of course, you can check that by plugging 2 back in. All right, so addition property of equality. The of equality just means that we have an equal sign. All that says is that if I have an equation and I add something to one side, I have to add the same thing to the other side. You're familiar with that, I hope. A and B are arbitrary values. Arbitrary meaning that we can plug in any value for that and produce an equation. We can produce equations that are true and equations that are untrue. But when we're trying to solve these equations like 2x plus 1 equals 4 or 2x minus 1 equals 5, we want to apply those properties of equality. Now, the other new thing that you might not be used to doing is justifying each step. And that's really important that you become familiar with that, because in geometry especially, you're going to have to justify or prove your arguments. So we want to prove that the solution to this is -2. To do that, I'm just not going to only write down those inverse operations. I'm also going to write down the properties that those inverse operations fall under. So if I'm going to solve this, what do I do first? I add 3. We all know that. Now, to justify it, on the side, what I'm going to put is the addition property of equality. You don't have to spell the whole thing out, but you can write add prop of equality. That's a justification. I'm making an argument using steps. Then I'm going to draw my line, and I have x equals -2, and like every good student, I'm going to circle or box my answer. If I want to check to see if that's correct, I just plug it back in. So that just took one justification, which was your addition property of equality. Questions? Okay. Let's move on. Okay, so I obviously subtracted. I justified that step because I asked you to justify. Reflexive property, I think of reflexive property like your reflection. You look in the mirror, you see yourself, it just allows you to switch. We read mathematics from left to right. We want our variable to be on the left. So what allows us to switch from -1.9 equals y to y equals -1.9 is that reflexive property. And then, of course, I'm subtracting on the second one. Put that justification. You don't want to put SUB period because we have a substitution property. Do you have any questions on these and what's expected of you? Okay. Multiplication and division, same thing. Whatever we multiply on one side, we have to multiply the other side. We don't want C to be 0 because if I multiply by 0, I just get 0 equals 0. That doesn't really help me solve anything. With division, if I divide one side of the equation by a particular number, I have to do the same thing on the other side. I don't want to divide by 0 because that's what? Undefined. Okay, so we don't want to divide by 0. Blow up the universe. So -n divided by 5 equals -3. So what's my first step in solving that? Yeah, that multiplicative inverse that we talked about is going to get me 1, right? So I'm going to multiply by 5 on both sides, or -5 to get rid of the negative all in one step. It says justify each step, so I'm just going to write multiplication property of equality. That 5 and that 5 cancels out to make the 1. And then I got rid of the negative in one step, and I got 15. And I circle my answer. Questions? Nice review. You try these. There we go. All right. So, word problems. I don't know many people that enjoy word problems, but they're there and they exist and we have to solve them. So in order to solve these word problems, there are a number of strategies that we're going to employ. One thing that I'm going to try to get you used to that is something that a lot of students don't like at first is step up to writing in math. So you've done step up to writing in an English class before, and you're going to do it in a math class. And basically what that's going to allow us to do is write really good explanations as to how we solved the problem. But to actually solve the problem and to come up with the correct solution, you want to make sure that you're identifying certain things. You're unknown. What is it that you're solving for? What do you have to solve that problem or that will assist you in solving that problem? And what strategies can I employ to solve those problems? The biggest piece of advice I can give you for high school mathematics is to try something. One of the big mantras of the school is perseverance. We want you to persevere, and in order to do that, you have to try. Even if it's going to get you the wrong answer, that's okay. We'll help lead you to the right answer, but you have to try something. So we're going to take a look at 2 word problems, and then we'll be done. Notes are normally not this long, I promise. You do not have to write this down. You can just write example 3, page 6. So it says in 2012, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed. When we have to write that equation, what we're doing is modeling the math problem. So write and solve an equation to find his average speed to the nearest hundredth of a meter per second. What am I trying to find? Average speed. So I'm going to write that down. Average speed. Average speed, which is also called a rate. What do I have that is pertinent or important information? Yeah, I've got a time. What else is important?
200 meters.
Yep, 200 meters is the distance. Well, I have a distance, and I have a rate, and I have a time. What equation can I use? Yes. Not distance formula, but that's a great guess. Distance equals rate times time, or dirt. Distance equals rate times time. Good one. It's a very good one to know. So I'm going to plug and chug. What do I have for the distance? 200. I don't know the rate. I know the time is 19.32 seconds. I'm going to solve for that R by dividing. The other thing that I need to be aware of is this part. Round to the nearest hundredth of a meter per second. So when I'm rounding, am I going to use an equal sign? No. Bear with me, we're almost done here. What does it look like? Do you remember? A little wave.